Now let's talk a little about referencing. Now, one of the challenges in trying to produce training materials about the NIEM is that everything is interrelated. So sometimes you have a topic pop up before you've actually talked about it, but you can't talk about that subtopic first because it depends on knowing things earlier. Referencing is one of those things. We mentioned it earlier. We talked about inside of entities, you had a person reference and an organization reference, and I kind of glossed over them. The reason being was I didn't want to get to them yet in detail because I knew they were coming up now. So let's talk about referencing. Now, most typical XML is strictly hierarchical. That's just how XML tends to work. You've got a root element, you've got elements inside the root, you've got elements inside those elements, and that forms a hierarchical tree. But XML doesn't have to be that way. XML allows for referencing across the hierarchy. There are ways to do it. There are ways to say this thing over here is related to this other thing way on the other side of the tree at a totally different level. There are things in XML to do that, and the NIEM uses that. The NIEM uses it a lot. And that makes the NIEM less hierarchical than most XML usually is. The NIEM ends up being much more relational with a lot of peer-level objects that are related to each other instead of a big, giant, vast hierarchy. The NIEM uses referencing to show these relationships between objects, and those references take the names of roles, associations, and metadata. Now, I've actually said a couple of these words earlier. You've probably seen association in some examples. You've probably seen role in some of the examples. I don't think we've seen metadata much at all other than in the early XML materials. But these are all NIEM concepts that use referencing to basically link different things together. So first let's look at why we do referencing, and then we'll look at some of the details of it. Consider cats. Why? Because everybody loves cats. Well, okay, not everybody loves cats, but the internet sure loves cats, and I have lots of cats. Consider two cats. Consider a beautiful white cat named Snowball, but spelled like the symbolic programming language, because if you're going to name a white cat Snowball, you should at least spell it in an odd manner. Now, Snowball has an owner, and that owner happens to be me, Tom Carlson. Now, there's another cat, and that cat is Nikki, and Nikki has an owner. That owner's name is Tom Carlson. Now, I'm actually completely lying because Snowball is really my wife's cat, and while I do have a cat of my own, her name is Einstein, and Nikki is not my cat. Nikki is Einstein's cat. It's all rather bizarre, but for the sake of this example, we'll pretend both these cats are mine. But is that true? Is this the same guy? You know, Snowball's owner's name is Tom Carlson. Nikki's owner's name is Tom Carlson. But are we sure it's the same Tom Carlson? Now, depending on where you live, this may be less of a problem. If you live on the mid-Atlantic coast, where I currently live, it's not really much of a problem. There aren't a lot of Tom Carlsons around. Interestingly, Carlson's kind of an oddball name around here, and some people have trouble pronouncing it. They want to pronounce it Carson, and the L really throws them. So here in mid-Atlantic coast, if Snowball and Nikki both have an owner named Tom Carlson, chances are it's the same guy. But in Minnesota, where I grew up, Tom Carlson is a horribly, horribly common name. At any given time while I was in college, there were 3 other Tom Carlsons enrolled. My Little League team had another Tom Carlson, and he was better than me, so I was Tom Carlson number 2. I actually had that written on my glove, Tom Carlson number 2. So if you're in Minnesota and you see 2 cats, both of whose owner's name is Tom Carlson, there's really no guarantee that's the same guy. How do we deal with that? I mean, we don't want to think it's the same guy if it's not the same guy. Luckily, XML has a way of doing that. On the left, we see kind of the hierarchical way of doing this, where inside of some big root element, we might have a cat object. Now let me be clear, there is no cat object in the NIEM. This is totally made up out of the NIEM. We have a cat object, and the cat has a name, and the cat has an owner, and the owner has a name. So we've got one cat, the name is Snowball, and the owner's name is Tom Carlson. We have a second cat with the name Nikki, and Nikki also has an owner, and that owner's name is Tom Carlson. But we're left with the question, is that the same guy? And there's really 2 problems with this. Number one, if we're assuming it's the same guy and it's not, that can be a big problem. Now remember I said at any given time there were 3 other Tom Carlsons enrolled while I was at college? One of them passes bad checks. Well, maybe he still does. I mean, if you pass bad checks in college, you probably still do. But he would pass bad checks, and that would mean I could never write a check anywhere, because anywhere I went to write a check, there was always a notice saying, don't let Tom Carlson write a bad check. Now, I have never written a bad check in my life, but still, I could not write checks anywhere near the college because they all knew not to accept checks from Tom Carlson. It wasn't me, it was a different Tom Carlson, but still, you don't want to assume it's the same person if it's not. A secondary problem is one of repetition. Here we've repeated the name Tom Carlson twice. Now that doesn't seem like a big deal. So what? We have the name Tom Carlson there twice. Who cares? Well, what if it's more than just a name? And what if it's a whole bunch of information about that owner? What if it's an image of that owner? What if it's a whole set of files of some sort attached to that owner? We're replicating all that information twice. At some point, that becomes a problem. That becomes a problem in terms of storage, and that becomes a problem in terms of transferring the information from one place to the other. Even in today's world of broadband, you really don't want to send huge chunks of repetitious information back and forth. It's a waste of resources to do so. So we don't want to do it this way. We want to know that that's the same guy, and we want to not send repetitious information. So that's why we have the version on the right. Here we have a cat, name of Snowball. It has an owner, and the owner's name is Tom Carlson, but it has an attribute in the owner that's S:ID equals, and then a string forming some sort of ID. In this case, ID 001. Now S:, that's structures. That's one of those infrastructure namespaces for the NIEM. And it provides this ID. It's based on an XML schema ID, which is uppercase ID. We take it and we make it lowercase and use it for our own purposes. The value of that attribute is an ID. Now the rule for the ID is that it has to be unique in a document. So if there's another object in this document that this cat object is in, and it has an ID of ID 001 as well, that's going to cause a validation error. It has to be an ID. Think of it as, as an ID, something like a social security number. I've got one, and it's unique. Nobody else has it. So each ID needs to be unique. Any object that has an ID, that has to be a unique ID. But the ID itself can be a string, it can be numbers, it can be a combination. It really doesn't matter. It just has to be unique in the document. A second important thing to remember is that that ID cannot be meaningful. It doesn't have any meaning outside of the document. It's just a string to identify something uniquely in an XML document. So that's not where I would put, like an owner ID. That's not what this is for. In fact, things in the NIEM have all sorts of identification objects for providing just that. So this is not a real-world ID. This is an ID that exists solely within an XML document. Okay, we've talked enough about the ID. Now we see the second part. We see the cat object with the name of Nikki. Now, Nikki's owner, we don't list the name. Instead, we list a reference, an S:ref equals. And again, S is the structure's namespace, it's infrastructure, and this time it's a reference. And the ID equals ID 001, the same value as the ID in Snowball's owner. So what this actually does is it's a reference. It points. It says Nikki has an owner, and that owner is whatever object has the ID that's listed after the ref. So in this case, it says Nikki has an owner. That owner is the object referenced by the ID 001. And so we can scan through, find the object that has the ID of ID 001, and see, oh, it's the same owner as Snowball, whose name is Tom Carlson. Now in this case, we know it's the same guy. We're not going, is this the same guy based on the name and hoping it is. We know it's the same guy because the second instance points up to the first object and says it's the same guy. I'm not a separate owner object. I'm the same owner that's up above in Snowball's cat object there. So we know it's the same guy. The second benefit is we're not repeating information. We don't repeat the name a second time. We just have it once in the one owner object, and the second owner object points to it. So we're avoiding repetitious information. And if there was a whole lot of data about this owner, then we wouldn't be repeating it. We'd only have it once in one of the owner objects. Now, everything in the NIEM can have an ID. It doesn't have to, but everything can. And they can point to different things that way. Now, normally in the NIEM, we don't just do it willy-nilly and put IDs on everything and then throw refs all over the place. We put the IDs wherever we need an object to have the ID. But the refs, we actually encapsulate inside reference objects, and then those reference objects go inside things called roles and things called associations. And we also have a special version for metadata. So let's start looking at some of these details. The NIEM uses 4 different attributes to implement referencing between NIEM elements. The first is that ID we talked about, which uniquely defines an element, and pretty much any object can have an ID. You put them on whatever objects you need to point to. The S::ref points to elements via the matching ID value. So if I got an ID on an object equal to whatever string, I can have another element point to it by using the ref equals and that same string. There's also a metadata attribute, and that's similar to the ref. It points to applicable metadata objects. Now we're going to talk about metadata in more detail, but right now you have to know is that it's kind of the same as the ref, only it's specifically saying, hey, this is metadata for me. Again, we'll talk more about it. And then the last one is link metadata, which points to applicable metadata objects in terms of an object's relationship to its context. And what does that mean? I don't know, and I can't find any more information about it than that. So if you figure out what link metadata means, let me know and I'll update this slide. But right now, I know it's there. I know there's a definition in the NDR for it, but I don't really know well how to use it. So we'll just leave it at that. Before we start looking at the individual objects in the NIEM and concepts in the NIEM that use referencing, let's just take one quick overview of what the end result of all this is. And the end result is that NIEM exchanges, things you build with NIEM, tend to not look like plain old standard hierarchical XML. This is what plain old standard hierarchical XML looks like. And this is what the NIEM's hierarchical dash relational kind of hybrid XML looks like. Instead of a deep hierarchy, you've got a bunch of peer level objects with relationships hooking those objects together. And some of those are going to be roles, some are going to be associations, some are going to be metadata, and we're about to talk about each of those so you'll know a little more what I'm talking about. But that's what the dashed lines are. We've got these different peer level objects all wrapped up in an exchange, and they're connected to each other via these various relationships.